Hi, my name is Nathen Harvey. I am a developer advocate at Google. And I'm going to talk today about this catchy title, Cloudy with a Chance of Chef. And it's really about automating Google Cloud Platform, or GCP, with Chef. And what this is really going to be is sort of a quick survey of some of the ways that you can use Chef along with Google Cloud. So just a quick show of hands, how many of you are interested in Chef? It should be an easy one. We're all here at ChefConf, so that's good. How many of you actually use Chef on a regular basis? Okay, how about InSpec? InSpec? A couple of folks. How many of you have never heard of InSpec? Okay, good, one person, that's awesome. How about Habitat? Who's using Habitat? All right, sweet. Well, I would love to show you how to use Chef, InSpec, and Habitat with GCP over the next 40 minutes or so. So if you're down for that, you're in the right room. If what you're here for is we want to dig super deep into the nitty-gritty details, we're not going to do that over the next 40 minutes, but we have a team of folks here from Google Cloud who can totally talk to you about that all day, today and tomorrow. So this is how you cloud. There we go. Now it works. See? Eventually, it will listen to me. Right, that's me. You can follow me on Twitter if you like. I will tweet about the beers that I'm drinking and the corned beef hash that I am eating. Yeah, so. Am I Irish? Yes, yes I am, indeed, yeah. Yes. So I have a document with a list of places in Seattle where you can get corned beef hash. Yeah, I'm happy to share that with you. Yeah, and if you ever decide to go work at Chef, it's part of the new hire orientation. There is a link to a curated list of places to get corned beef hash. Yeah, all right, I got you handled, sorted, no worries. Right, so this talk, as I mentioned, is all about GCP and Chef. But first, I just want to start off and kind of level set. So GCP, or Google Cloud Platform, came out of this little company called Google. We have a search engine. I don't know if you've heard of it. Anyone heard of Google before? Okay, yeah, cool. Which is kind of awesome because, we run big data centers. But you might be thinking to yourself, yeah, so what? I'm not Google. How many of you are Google? Okay, good. I have some colleagues over here that aren't lying today. That's good. Yeah, so one of the challenges with Google is we have a pretty big infrastructure. We have an infrastructure that might be bigger than yours, might be different than yours. That's not because we're better, we're just different. And so we have challenges that are very similar to yours, but we also have challenges that are different than yours. And we created this thing, Google Cloud Platform. And GCP really was this idea that we could take the best of Google and make it available to you. By doing that, we can introduce better tooling for you to use as you make your journey to the cloud, but we can also introduce some better practices. So that's really what we're all about. And we at Google, we recognize that it's not just the tools that make you better. It's not just the tools that allow you to move faster. It's not just the tools that allow you to move safer. You also have to change the practices of how you work. So maybe you were here in the last talk where Domenico was talking about Kanban and measuring and eliminating work in progress. All of these are changes that we have to make to the way that we do work in order to better serve our customers. How many of you care about security and reliability? All right, good. How many of you are tired of me asking you questions in which you have to raise your hand? All right, good. So you're also lying, because if you were really tired of that, your hands would have stayed down. Maybe not surprisingly, Google cares a lot about security and reliability. There's the typical view of security, like we will put everything in a fortress, and we will protect all of our stuff. This is a great view of security, and this is kind of security in real life. That egg is pretty easy to get into. The yolk is kind of runny. It looks delicious. How many of you thought before you walked in that we would say that security was delicious? Like, that's pretty awesome. So we have this delicious security. Security is a real problem. Google takes security very seriously, despite maybe my jokes about the runny eggs. And our security, our approach to security in basically 2 words is this: trust nothing. And that's really how we've built our cloud. We've built our cloud with a full sort of defense and depth security, and we think about all of the layers, everything from the hardware, so the actual CPUs and the hardware where your workloads are running, all the way through to how you're using it. And we have security built in at every single layer, and we really, as I said, we don't trust anything. Another thing that's kind of cool about GCP that you might not be aware of is this idea of live migration. So when you run a workload in GCP, you might spin up a virtual machine, or maybe you're running on some Kubernetes cluster, or what have you. We have the ability within GCP to actually migrate your workloads from one physical machine to another physical machine without having any impact on the service that you're receiving. You might not even know that we did this. We do this completely seamlessly to the user. And that is, it's pretty awesome. And if you think about how can you use that, or what's a real world example of that, think about Meltdown Inspector. Every single piece of hardware, every compute instance or every computer that we were running had to be patched. And we were able to do that across all of GCP without any downtime for our users because of live migration. So that was pretty cool. All right, that's the top high level, just a couple of things I want to share with you about Google Cloud. What I'd love to do for the next 20 minutes or so is just a bunch of demos. Are you all down for some demos? Doesn't matter what you say, because I'm going to do some demos, whether or not you're down for them. So I want to run through basically all of the big major components of Chef and how you can use them together with GCP. So we'll start off with infrastructure. And I also want to say, as I start this, that I just want to remind you, or if you came in late, this is a survey of how you can use all of these things. We're not going to go super in depth into any of them. I'd rather go wide than deep on any of them. And I'm also making some assumptions that you have at least some experience with Chef, or some of the terminology and so forth. But whatever, I'll talk about it as we go through. So first, let's just move over here to, we're going to move over to GCP. So this is, let's see, I can make this a little bigger so you can maybe see it better. Can you read that in the back? Doesn't matter, you don't have to, it's cool. So this is the GCP console. If you've never seen it before, welcome. This is your home, this is the GCP console. One of the things that's awesome about GCP, not dissimilar to some other clouds, is we have a cloud shell. So I'm just going to click this button to activate my cloud shell here, and that's just going to do that, and we're going to make sure that the Wi-Fi and all that stuff is working. While that's running, I'm just going to move this cloud shell into a full window so we can see it a little better. So the Cloud Shell, one of the things that's amazing about Google Cloud Shell is you have a built-in development environment. This Cloud Shell is accessible through a browser. You can do all of your development work within this Cloud Shell. And in fact, you can create a custom Cloud Shell that has things pre-installed in it, so that when you have a new member of your team, you can say, just launch the Cloud Shell. All of your development environment is set up. All of the kit that you need, whether that's Test Kitchen or Chef Workstation, it's already installed in our custom Cloud Shell. And so you can just go ahead and use it. So that's really, really handy, especially if you think about when you're traveling. I spend a lot of time on airplanes. I can usually get an OK connection across HTTP. I can do actual development work that's happening on the cloud without tearing up all of the resources on my laptop. So here I am in the Google Cloud Shell. Let's just make this a little bit bigger. Yeah, it's pretty good. OK, so the first thing I want to talk about is using Chef with Google Cloud. So Chef Infra. How many of you have written a cookbook before? You don't have to raise your hands. I'm going to stop asking you questions. So let's just look at a cookbook that I wrote. So not only do I have a shell here, but I also can actually edit code right within this browser as well. I have a nice little code editor here. So we're not going to look at that Docker file. You didn't see that. Definitely not part of this demo. So I have a little cookbook, and it's really simple. Let's see, some audience participation. Can someone tell me what this cookbook does? It doesn't do Hello World. Well, maybe it does at the end. I'm not sure. Yeah. Yes, it installs Nginx. That's all this cookbook does. But that's not the interesting part. That's not the part we're here to see. What I do want to talk about, though, is Test Kitchen. So how many of you, I told you I would stop asking you questions about that. So I'm just going to close this code editor here, and I'm just going to look at a kitchen file. Right. OK, so when you're writing cookbooks, one of the most important things that you do when you write cookbooks is you test your cookbooks. You want to run your cookbooks in a sample environment or a test environment before you run them in your production environment. The best way to do that is through Test Kitchen. So if you're unfamiliar with Test Kitchen, the quick TLDR on Test Kitchen is this. It's a test harness for testing out your cookbooks. You can use Test Kitchen to spin up infrastructure, put your cookbooks onto that infrastructure, execute those cookbooks, and then verify them. Make sure that they did exactly what you expected them to do. So when we walk through that, where do we spin up the infrastructure? Sometimes you just want to spin up a local VM using something like Vagrant or VirtualBox that's running on your local machine. But oftentimes it makes sense to spin those up off of your machine so that you're not utilizing all of your resources, like maybe you have slow CPUs or not enough RAM, whatever. You want to run them in a cloud. And in fact, you can also get much closer to what a production instance might look like when you run that Test Kitchen in a cloud. So Test Kitchen itself has a bunch of plugins that allow you to specify where do you want to spin up that infrastructure. And so we can use Test Kitchen along with Google Cloud using the GCE, or Google Compute Engine, Kitchen plugin. So that's Kitchen Google. And it's pretty easy. So we give it, ooh, not that. So we give it a couple of things. So we give the driver a name. We tell it which project we're working on. So another thing quickly about Google Cloud, all of the work that you do within Google Cloud is organized into projects. So you can think about projects maybe as different applications or different services that you're working on. The nice thing about this project hierarchy is it groups all of those resources together. At the end of this, I could go and delete a project, and any resource associated with that project gets blown away. So whether that's volumes, compute engine instances, instance groups, load balancers, firewalls, when I delete the project, all of those resources go away. I don't have to go hunting and pecking around to find all of the resources that I'm no longer using. So I'm setting up just some simple stuff here, the project, some tags, an SSH key. We're just going to provision it with Chef 0. We have a verifier that I'm not going to use because you should always test your cookbooks, but not today. We're not going to do that. We're going to run this particular kitchen with one instance. So we're just going to test it against Ubuntu 16.04. And we just provide some metadata so Google will know, or Google Cloud will know, which type of instance to spin up. So we're just going to grab the latest Ubuntu 16.04 instance, and it's going to create an image for us, or a cloud instance for us. So before we look at that, let's just come over here and look at our compute engine. And we can look for VM instances. You can see here that I have a Chef Automate server already running, or at least I have an instance that's named Chef Automate. But I'm just going to go back into my Cloud Shell, and I'm going to run kitchen converge. OK, so while this is running, here's what's happening. Absolutely nothing. You see that? All right, let's see what's going on here. Oh, I couldn't load the driver. That's nice. Let's see. You get to watch me live troubleshoot. Chef Gem install. Kitchen Google. Drivers are completely overrated, right. Do-do-do. See how that goes. Not so good? All right. See, remember what I told you about the beauty of Cloud Shell is you could set up a development environment, new developer walks in, and it just works, right? All right, that's looking much better. So Kitchen Converge, what's happening? Nope, it's not looking any better. Oh, it couldn't load the InSpec verifier. All right. The beauty of Cloud Shell. Do you see it? It's amazing. Yeah, raise your hands if you see it. Right. Well done. Thanks, Eric. Oh, it's good. I'm installing the documentation also. I'm glad I didn't pass that flag to skip that bit. Yeah, please. Yeah. Yeah, so the question there was, speaking of setting up your development environment for Cloud Shell, is there some sort of templating that you can do? So the Cloud Shell itself is actually a Docker container. So what you do within Google Cloud, within the UI, you have this sort of wizard that walks you through, here's the Docker file, and you can now you can customize your Cloud Shell exactly as you want based on this new Docker file. So you can install new things within that Docker file. And then what you do is you actually take that Docker file, and let me type and talk at the same time, because that always works well. And still no good. We're gonna just yeah, it's beautiful. It's beautiful. It's cool. So you're gonna trust me. I run Kitchen Converge. It creates an instance. We can now test that instance. But back to Sean's question. So how do I get this how do I get my Cloud Shell set up? There's a baseline Docker image, and we basically can layer stuff on top of that and install things. When I save that Docker image, what I'm doing is I actually put that into a cloud source repository. So we have like our own sort of Git repository functionality on Google Cloud Platform. And then a cloud build job is created around that. So what happens, what that cloud build job will do is anytime the baseline Cloud Shell changes, so the one that's officially published by Google, if that changes, or if your Docker file, so your container that's built on top of that, if either of those things changes, Cloud Build will automatically kick off, build that updated Cloud Shell, and then when you come in and launch your custom Cloud Shell, you'll have that there. All right? Right. So the TLDR there, and I'm sorry that the demo isn't working, but also that helps you know that the demo is real. That sounds good, right? Is that would launch an instance on GCE, and then we could run it with Test Kitchen. We could do all of the Test Kitchen-y things. Now, instances on GCE, how are they different when you run them with Chef? The beauty of Chef is Chef don't care, right? We have an instance, we have a node that we want to configure. You'll configure it the same way you would with anything else. And it shouldn't matter if it's a local VM, if it's a GCE instance, or what have you. So let's next look at Chef InSpec with Google Cloud. And let's hope that this works a little better. Let's see. Yeah. Yes, it was not very happy with me. But that's all right. We're going to just move right on and see what we can do here. Let's cd to lab 1. OK. So if you've never seen InSpec before, here's some InSpec for you. We're going to find out here in a second how this goes. If not, I'm thinking of a way to get that solved. Anyhow, this is going to describe my local system. So I'm running some tests locally within my Cloud Shell. I should have the OS environment should be Cloud Shell. It should be a Google Cloud project. And there should be some Terraform installed here. So let's just see what happens when we run that. So we'll run those local tests. Hey, look at that. Totally works. No? Yeah, we can. Hey, that's awesome. Go Google Cloud. All right. So we can run tests locally, which is fine. Like you should be able to run tests in your local development environment, but that's not really telling us much about GCP itself. So let's see, what other sort of tests do we have? We actually have some GCP tests. Let's just take a look at those. So here's a GCP test. We're going to check or describe a Google project. And that project that we're going to describe is the one that we're currently working with, our current Google Cloud project. It should exist. Its project ID should be equal to its project ID, basically. And its life cycle state should be active. So this is a way that we can use InSpec, not just to check a local operating system, but actually to go against the GCP API and inspect something about what's happening in GCP. Yes? Yeah, that's a great question. So could I just list and see everything that's part of the project? So not in that particular, or not in this particular profile, but if you stop by the GCP booth later today, Sam actually demoed something earlier today. He's built an InSpec generator thing that will look at your project and actually build controls or profiles for everything that's in your project. That's exactly right. That's exactly the idea behind that tool, is that we can configure it however we want, run this InSpec generator against it, and now I have InSpec tests for every resource that's part of that project, and I can just run those in a loop to make sure that my project doesn't drift. I can keep them all there. So here we go. We see that this project exists. It is active. We're in a pretty good state. Now that's fine, but we can also provision a bunch of other stuff. There isn't really a whole lot within this project. So let's just look at what it looks like to provision more things within this project. So one of the other things that we have within the Google Cloud Platform space, as associated with Chef, is we have a bunch of cookbooks that you can use to execute basically Chef provisioning to launch a bunch of things within Google Cloud. But the truth of the matter is, as a community, we have kind of moved beyond Chef provisioning and have adopted Terraform as the way to go and provision instances within the cloud or within your data center or wherever you want to do that. So I actually have here in this directory some actual Terraform that's set up. So let's just let's deploy some stuff with Terraform. So I'll just Terraform init, and it wasn't happy about that because it looks like it's running the wrong, I have the wrong version installed, but that's cool. I know how to fix that. Give me 1 second. Let me jiggle the cord here a little bit. All right, Terraform init, which just gets all of the plugins that Terraform needs. If you've never seen Terraform before, stop by the booth. We'll tell you a little bit more about Terraform. So Terraform, what we can do now is I can run Terraform plan, and I can just write that out, dash out to plan.out. And so the way that Terraform works, this is basically Let's figure out what do we need, what does our plan define, or what does our Terraform setup say that we should have deployed, and we're just going to test that. So I see here that if I run Terraform plan, I have 7 resources that I need to add. So this particular Terraform setup is going to just create a load balancer. It's going to create a bunch of instances and get those deployed. So I'm going to go ahead and apply that. Let me... All right. Now, the rule about typos that I failed to tell you at the beginning is when you see me make a typo, you have 2 choices. You can stop me and help me correct the typo, or you can wait and laugh. It's your choice. Either one is fine. You can do either of the 2 things that you like. Okay, so this is executing Terraform. What Terraform is doing is it's saying, hey, I should have 3 web servers that are running. Those web servers should sit behind a load balancer. There are probably some firewall rules that I should have executed. Let me go ahead and check with GCP. None of those things exist, so I'm going to go ahead and create them all. So Terraform is now off creating a bunch of stuff for me. We can see, it's going through. It's creating a firewall rule right now. And if we come back over here to our compute engine and we refresh the page, we're going to see that I have 1, 2, 3 web servers that have now been deployed by Terraform. This is just running along. OK, great. So that apply is complete. All of my resources have been set up, and I have the system in place. So I'm in really good shape. And what I can do now is in this directory, I also have a couple of different tests. I have some functional tests, some GCP tests, and some integration tests. And I can run all of those using InSpec. Let's just take a look at, I don't know, pick one, functions, GCP, or integration. What do you want to see? All right, functions. We'll take a look at the functions. Let's see what's happening in there. OK, so this is describing a Google Compute firewall. And it's saying that HTTP should be allowed, and it should be allowed from anywhere. Right? So we've written an InSpec test that says we should have this firewall rule in place, and it should allow for HTTP traffic coming into all of our web nodes. So I can just execute that, InSpec, exec, function. And then what I'm passing here is a -t, or a target. And typically, if you're running InSpec against a remote node, you would specify like the IP address for that node with the SSH credentials or the WinRM credentials. But we're not executing it against a specific node. We're executing it against GCP. So our target in this case is going to be GCP, ://. We're going to execute that functional test using InSpec. And it's going to come back and tell us, yes, that firewall rule is good to go. There we go. So our firewall allows HTTP. The beautiful thing about this is we can start introducing a test-driven development workflow to our Terraform setup. So I can actually write some tests, watch them fail, write some Terraform that allows those tests to pass, or that configures the system the way that we want, and then run those tests again and see them work. But there's one little issue that I also want to show you, because testing out that Terraform stuff, actually Terraform has some built-in controls that will do that for you. So now that I've applied my Terraform, I can actually run that, thank you. I can run that Terraform plan again. So let's just run Terraform plan and see what happens. So I've already set everything up. If I run Terraform plan again, it says, hey, everything's already set up. I don't need to take any actions, right? So that's great. Why do I need InSpec if Terraform can tell me that you're still in a good state? Well, the reason that you might need InSpec is, what if you have someone who has control of your systems, like a sysadmin who decides, what I need to do is I need to get this file onto this server. But you know what I forget every time is how to SCP. But what I remember all the time is how to FTP. because I have a really good memory of back in the day when we used to FTP things, and all this new stuff like SCP, forget all that. So the first thing I'm going to do is I'm going to create a new a firewall rule. So I'm going to stop talking while I type, because otherwise I will type the words that I'm saying. So I'm going to gcloud. Gcloud is our command line utility for interacting with GCP. So I'm going to create a firewall rule. I'm going to create one. I'm going to call it takeover, just because I want everyone to know that this is a thing that we shouldn't do. I'm going to allow. If you would stop watching me type, I would type better. I'm going to allow TCP over port 21 with some target tags. I want to allow that for all of my dub nodes. Yeah, so I'm just going to open up this new firewall rule. I'm going to go ahead and create that. Great, it looks like no typos. Thank you for helping me along with that. We'll give this a second. Now, our Terraform did not say to create this firewall rule. That firewall rule has now been created. It exists there. So what happens if we run this Terraform plan again? Right? Yeah, it's going to say it's OK. There are no changes to be made. But my infrastructure has drifted. My configuration has drifted away from what we set it up to be. So that's kind of a problem for us. That's where InSpec really comes in and helps us shine. So let's just look at, we looked at the function. It might be I don't remember if it's the integration or if it's the GCP test. We're going to find out in a second. Yep, it's here. So we have this GCP test. Oh, why don't I open it up in the editor so we can look at it there. Or why don't I not? That's cool. We'll look at it here. So we have this control. And what we're going to do is we're going to grab all of the firewalls. So grab all of the firewall rules that are configured on GCP. And then we're going to loop over them. So we're just looping over each one. And then for each one, we're going to say that it should not allow port 21. That's a 21, even though, yeah, you can read that better if I don't highlight it. So when I execute that, so inspec, exec, GCP tests, and then my target that I'm targeting is GCP. Guess what we're going to find? We are going to find an error, because now we have this rule that's allowing port 21. And this, when we find this error, what are we going to do? Maybe this error kicks off an alert. Maybe it sends a message to Slack. Maybe it opens up a ticket in ServiceNow. We have to do something to respond to this. And so we can see here that there's a firewall rule called takeover. It allows things on port 21. That's a problem. But we actually saw two failures. So we know we have the one firewall rule that fails. But actually, if we look at this output, there's another one, the default allow internal firewall rule. That basically allows any port to any port within my VPC network. So everything is open there. Maybe we don't care about that. Maybe we just skip that in our inspect control. Who knows? But this is why it's important even when you're using Terraform, something that's going to keep your systems in the described state. If you have InSpec that can help you test all of those, that really helps. Make sure that there isn't drift, any configuration drift. All right, so let's move on to the next thing that I want to show you from there. Now that we've looked at, so we had a failed Chef Infra implementation. We had a working Chef InSpec implementation. That's good. Let's look at Chef Automate. Because there's some really cool stuff that you can do with Chef Automate, specifically around the InSpec GCP connection. So over here I have a Chef Automate server. Maybe you've seen one of these before. Let me make it just a little bit bigger. So one of the things that you probably know about Chef Automate is that there's a compliance section. And within compliance, you can set up a bunch of InSpec profiles. And in fact, the Chef Automate server itself comes with an asset store with 100 today. It ships with 149 available profiles. None of them have been installed here, so I just want to walk through that process. Let's look at the 149 available. We're just going to search for the GCP ones. And it turns out that Automate ships with 2 profiles for GCP, and in fact, they're the CIS profiles. So maybe you've heard of CIS, the Center for Internet Security. Chef has written InSpec profiles that validate that your GCP project configuration is following the benchmarks, the CIS benchmarks for level 1 and level 2. So I'm just going to get them both, just download them. And so when I click on Get, that basically gets them installed into my Chef Automate server. So now, instead of having to run those InSpec tests from either my local machine or from my Cloud Shell, I can actually configure Chef Automate to run those InSpec tests against my configuration. And the way that I do that, if I come over here to the Scan Jobs, I can create a new job. Oh, wait, sorry. I think I want to come over here first to Settings and go to Node Integrations. So I'm going to create a new integration. Oh, but there's a problem. Yeah, now my demo has really gone off the rails. Damn. Oh, it's OK. I know how to fix this. This is cool. One of my favorite features of Chef Automate, not like a deep feature, but it's pretty cool. Maybe you've seen this. Chef Automate ships with feature flags. And when you build applications, it's cool to ship with feature flags as well. The way that you access the feature flags within Chef Automate, I'm just going to click anywhere on the screen, so that's active, and then I'm going to type beta. So I typed beta, and look, this thing pops up. So now I have access to all of the beta features. I think that's the most ridiculously awesome feature of Chef Automate. But one of the things that I can do is I can turn on Google Cloud Node Manager. So now I've turned on this feature flag. This is super cool because we want feedback. Chef wants feedback from customers. And so we create this thing where you have access to the feature flags and can turn those on. So I'm just going to refresh this page. And look at that. Now I can integrate both with AWS and with Google Cloud. So that's pretty awesome. I'm going to come over here to Google Cloud. Of course, you have to provide. Yes, Harm, you have a question.
Yeah, the sys templating. When you update them as Google, and they get updated automatically, or is there a process for that?
I'm sorry, say that question one more time.
So you have the sys templates.
Yes.
There will be an update to it.
Yes, OK, I got you. All right, so the CIS profiles that we get with Chef Automate, those ship with Chef Automate itself. And in a month's time, that's a lie, probably 28 months' time, CIS is going to release a new version of them. No shame. Like, it will be sooner than 28 months, I'm sure. So how do we get those new updates into Chef Automate? There's actually 2 ways that we can get them in. A release of Chef Automate will always have the refreshed versions. So you can always pull, like, you should be updating your Chef Automate all the time, so you can grab them from there. And then if not, the other thing that you can do is you can actually upload your own profiles. So you could grab the profile that's distributed maybe with a later version and put it onto your older version of Chef Automate. Yeah. OK, I need to do a quick thing here. I need to cat some downloads. Yeah, it's cool. You can take pictures if you want. Right. I'm going to save that integration. And that's good. So what I've just done there is I just grabbed I have a service account for my GCP. I grabbed its credentials. I threw the credentials into Chef Automate. So now Chef Automate knows how to authenticate to my GCP. So now I can go over here to my Scan Jobs. And from within Chef Automate, I can create a new job where I want to grab, first, which user do I want to use? I want to use my credentials, the ones that I just set up. And I want to run let's just run the benchmark level 1 CIS profile. We can name this, and we'll just call this level 1. And we're just going to do an initial scan. Now, you could set a schedule here which is probably what you would want to do in the real world, like have this scan run on a daily basis or an hourly basis or what have you. I'll just save that. And so now that scan job has automatically been scheduled. So now what's going to happen is it's going to take that CIS profile, it's going to authenticate to my GCP account, and it's going to run those CIS benchmarks against my current GCP configuration. Now that's going to take a second to run. So do you mind if we do a quick, you won't even notice it, we're going to talk about something else, and then we'll come right back to this and see how it went. All right, I want to talk really quickly, because I'm almost out of time, about Habitat. So you've built some packages with Habitat. Maybe you haven't, doesn't matter. The beautiful thing about Habitat, you package up your application, all of its dependencies. You can take Habitat and you can export it as a Docker container. And so how are you going to run that Docker container maybe on Google Cloud? You have a bunch of different options. Of course, you could just run a standard compute instance and give it a container, and it will run that container. You could launch GKE or Google Kubernetes Engine and drop that container in there. But we also have this new thing that I'm pretty excited about called Cloud Run. So I just want to look at that really quickly. Cloud Run is essentially a serverless offering that we have. Like, there is no infrastructure. I just give Google Cloud Platform I give it a Docker container, and it will just run it for me. And I don't actually have to worry about anything from there. So let's just take a quick look at that, see what it looks like. Here's Cloud Run. So what I've done before you walked in is I took a Node.js application, packaged it up in Habitat, exported it as a Docker container, and then published that Docker container to Google Container Registry. So I'm going to create a new service. I am going to select that image, that container image that I've created. It's just a sample Node application. Some stuff here, and then I need to do a quick environment variable because this is running the latest version, and you know how licensing works. So let me just add that, and I'm going to create that thing. Yep, and it wants me to make sure that everything is selected. Sure. Unauthenticated sounds good, right? Oh, no, I don't need another one. Just one. OK, so I've handed Google Cloud Run this Docker container that has a Habitat package that's running in it. While that's running, let's just check back over here on our Chef Automate and see what's up. See if it's still running. Still running. There's lots of things in that CIS benchmark. So we're going to let those go. But I now have a URL that I can go to. And drum roll, no nerves here. Look at that. We're running version 1.1.0 of the Habitat Node.js sample application. So I took an application, packaged it up in Habitat, handed it to Cloud Run. Cloud Run will scale up and scale down based on my traffic, and you don't have to worry about it at all. Cloud Run just handles all of that for you. Nope, you don't have to specify a node type. This is like serverless. It is truly serverless, which means it's our computers, not yours. It's our servers. We'll handle them for you. All right, and it completed just in time because I have 1 minute and 30 seconds left. Let's look at our report. Our system is not compliant. Man, it would be great if we could spend some time to fix all of that, but we can't. But what we can do is we can see what's happening here. So I can see there are 20 critical controls that are failing. I might want to create my own custom wrapper around the CIS cookbook and disable these 20 controls, so at least I know I'm not getting worse. Or maybe I would need to stop everything and fix these 20 controls. As you know, hopefully, as you know, in Automate, you can dig in and you can actually read about the controls, and you can see the actual source from the controls that are failing here. All right, in the 30 seconds that I have left, I want to tell you something else that's awesome about Google, and specifically about Google Cloud. Google gives a shit about the environment. In fact, we give lots of them. And so we are big into environmental sustainability. We are the largest purchaser of renewable energy. all of our data centers run using about 50% of the energy that a typical data center uses. And over the years, we just get better and better and better at that. So Google, as an organization, has a carbon neutral footprint, which is pretty awesome. That makes me happy to work there. So we have a time check now. Thank you. Yeah. We have a time check. In the 0 seconds I have left, would you like to see a demo of Kitchen Terraform, a bonus round about SRE, or are we out of time? Well, it turns out we're out of time, so we don't get those other things. What I will encourage you to do is show up tomorrow for the keynote presentation. Dominic Richter is doing some really crazy stuff with cloud and artificial intelligence, and he's going to talk about that and sort of where his head is and what we're doing at Google Cloud around that. And then also tomorrow afternoon, Sam has a talk about the magic of custom InSpec resources. There's this really cool library called Magic Modules that you totally should check out. So you can check out that talk tomorrow at 3 o'clock. Not in this room, but you can check the app and find out which room that's in. And then this evening for the happy hour, do stop by the Google Cloud booth. We can demonstrate more stuff. I'm sure I can get that kitchen thing working, and we're happy to answer any questions. With that, I want to say thank you very much. It was great having you all this afternoon.